Hello, welcome to the Australia and New Zealand AWS Summit, and thank you for joining me today. Security is a huge part of building a successful business, and while the scale of security challenges and the level of scrutiny may differ between an early-stage startup and a larger, more established business, the fundamentals remain the same. At our annual Security Customer Conference Reinforce in 2019, the Amazon CSO Stephen Schmidt presented 10 critical areas of focus for securing AWS environments at any scale. Over the next 30 minutes, we're going to dive deep into each of these and how they're relevant to your startup. I'm Dave Barton, Principal Solutions Architect in the AWS Startups team in Australia and New Zealand, based out of Sydney. Throughout my career, I've worked in a number of security-focused roles, and interestingly, none of them had the word security in the title. It was just part of the job. Most early-stage startups won't have a dedicated security person or team, so it's vital that everyone takes responsibility for security. With that being said, it's not feasible for everyone to become a security expert, so those in leadership roles must build the right culture and install the right guardrails to allow their startup to build and innovate fearlessly. By the end of this session, you'll have the knowledge to start building a security culture that will protect your business, your customers, and your investors, while helping your startup thrive. We'd like to invite you to join us on the AWS Startup Loft. You can connect one-on-one with AWS startup experts in Australia and New Zealand to get your questions answered. There will also be technical and business startup events, workshops, and more, and we hope to see you there soon. At AWS, security is our number one priority, and we believe in the key role of security in building sustainable, successful businesses. We want to make it as simple as possible for customers to take advantage of the massive investments that we've made in the security and governance of the AWS Cloud. AWS has been architected to be the most flexible and secure cloud computing environment available today. Our core infrastructure is built to satisfy the security requirements of the military, global banks, and other high-sensitivity organizations. That's why we use independent third parties to audit the services against 98 industry standards, including PCI DSS, the payment card industry standard, and HIPAA High-Tech, the US healthcare data protection standard. It's why we make the results of over 2,500 security controls available in AWS Artifact, our self-service portal for customers to access up-to-date AWS compliance reports. It's also why all 117 AWS services which store customer data offer the ability to encrypt that data. And it's why we've built over 280 security, governance, and compliance services and key features into the platform. Working at the scale of AWS allows us to invest significantly more resources into securing, policing, and countermeasures than almost any large company could afford themselves. And our builders get to leverage that investment. But it isn't enough to be secure, though. After all, a switched-off computer is secure. It's about balancing security and velocity, but it doesn't necessarily follow that more security will slow your business down. With the right processes and tooling, security can be an accelerator for innovation in your business. For example, AWS have built and maintained more than 280 services and features focused on security, governance, and compliance, and we're nowhere close to being done. We also build security into everything we do, and compromise is never an option. And yet, in 2021, AWS released 3,084 new services and significant features. By thinking about building in the right way, you can get security and velocity. Now let's talk about how. Nothing is more important for great security than buy-in from leadership. They set the culture and priorities for their businesses, and it's critical that founders, CEOs, CTOs, and other business leaders consistently reinforce the need to put security at the heart of everything your business does. And I think what Adam says here is really powerful. If we don't have the right security in place, we don't have a business. And that statement is true of all businesses of all sizes. Okay, let's dive into Stephen's top 10 security areas of focus. Every AWS account has a set of contact details associated with it. These include the email address associated with the account, as well as optional contact details for billing, operations, and security. If AWS receives reports of abuse, such as mail spam, denial of service attacks, or other malicious activity coming from resources in your account, we will contact you via the security contact if it's configured and the account email address. If we don't receive a response and the malicious behavior continues, we may take action to protect the account as per our acceptable use policy. As such, it's vital that contact details are up to date and that emails from abuse@amazon.com are monitored and acted on. Best practices here involve using email aliases targeting multiple individuals, using a business email address as opposed to a personal email account, setting up the billing, operations, and security aliases, even if they all go to the same person or group today, and regularly checking that your contact details are up to date. You can change the alternate contacts as frequently as needed. Recovering the root user access when, for example, the associated email address belongs to a contractor brought in to help you get started, well, that's much harder, and that can take time. For obvious reasons, we maintain a very high bar when it comes to recovering root access to an AWS account. This is where I would normally ask for people who use the root account to manage their environment to put their hands up, but that doesn't work quite so well virtually. Let's cover off some basics. Every AWS account is set up using a globally unique email address and a password. This is called the root account. It sits outside the scope of the Identity and Access Management, or IAM service, and has full and unrestricted access to everything in the account. And while there are a few tasks which do require the root account, that list is growing smaller all the time. And currently, the documentation lists only 9 tasks requiring the root account to complete. These include changing your AWS support tier and changing account details such as the account name and the associated email address. Everything else can and should be done using an IAM user or role. The first recommendation here is to never use the root account except when setting up a brand new AWS account or for one of the 9 tasks mentioned previously. You should not create credentials, those are secret keys allowing access to the AWS API or CLI, for the root user, and you should ensure the root user has both a strong password and multi-factor authentication enabled. If you haven't come across the term multi-factor authentication, or MFA, it is the technique of taking something you know, such as a password, and adding either something you have, such as a hardware token or smartphone app, or something that you are, such as a fingerprint or iris scan. MFA is the strongest protection available for your accounts, and you should enable it whenever possible. And not just with AWS, I have 42 different accounts in my Authenticator app at the time of writing. When this comes to MFA, there are 3 common implementations: a hardware token, a software application, or SMS, or text message. Each of these is better than no MFA, but SMS is, for a number of reasons, considered less secure than the other options, and is no longer supported by AWS for new users and accounts. A hardware token offers the strongest possible protection, as it can be stored securely more easily, but a software application such as Authy or Google Authenticator offers a good balance of security and convenience. If you want to take the hassle out of managing multiple users across your AWS account, you can use AWS Single Sign-On, a free service which allows you to set up your users once and then grant them permissions to any of your accounts quickly and securely. AWS SSO supports MFA, and it's easy to configure access to both the AWS console and the AWS CLI for your users. Now, often, when a startup is first getting off the ground and trying to build something, there's not much differentiation between testing and production, and in fact they're sometimes the same thing. Or perhaps the CTO's laptop is the development environment. The usual goal is to get people using your product and providing feedback as soon as possible, because for many early-stage startups, the biggest risk isn't related to security at all. It's spending time and money building a product that nobody wants. As soon as you've got customers using your product, you can start to get feedback, but those users also bring something else. They bring data. And this could be anything from IP addresses in web server logs through to financial, medical, or other personal sensitive information. At this point, you really want a clear separation of production and non-production workloads. And even if you've only got one developer today, that won't always be the case, and not every developer needs access to that customer data. There are techniques for isolating workloads within a single account, from VPCs, virtual private cloud, to security group and network access control lists, to fine-grained IAM permissions, but these all rely on configuration, and you're only ever a single config change away from potential exposure. Separate accounts offer the strongest security boundary available in AWS, and building your development and production environments in separate accounts will give you a massive advantage when your team starts to grow. It will also offer a number of reliability, scalability, and performance benefits. And most importantly, it will let you tightly control who in your business has access to customer data. Having more accounts does mean having more stuff to manage, but using AWS organizations and infrastructure as code tools such as AWS Cloud Formation can take away much of the effort involved in managing a multi-account environment. AWS organizations allows you to group your accounts into organizational units or OUs and then apply controls to groups or to individual accounts. AWS has customers today using hundreds or even thousands of accounts, and organizations allows them to easily manage and secure them. Information security can be broadly broken down into 5 areas. Identify, which is understanding what assets your business holds and the associated risks. Protect, building proactive defenses to block or contain threats. Detect, building the capability to identify when and how your business is under attack or vulnerable to attack. Respond, ensuring you have the capability to respond effectively to detected security events or vulnerabilities. and recover, giving your business the best possible chance to get back to normal operations following a security event. And to be successful in any of these 5 areas, you need to be able to identify quickly what actions have been taken in your accounts and by whom. AWS Cloud Trail provides a log of all API activity, that is, calls to the AWS API to gather information or make changes in your accounts. Especially in a multi-account environment such as the one we discussed in the previous slide, these logs should be centralized and stored securely. The account used for this should be tightly controlled to ensure that the logs cannot be removed or tampered with. AWS offers a reference implementation of this solution which can be easily deployed using AWS CloudFormation at the address on the slide currently. It offers log ingestion, centralization, indexing, storage, and visualization using a serverless pipeline and a managed Amazon OpenSearch cluster. As you can see on the diagram, it's taking CloudTrail logs, VPC flow logs, and application logs from an EC2 instance and storing them in a central account using Amazon OpenSearch and Kibana for storage, querying, and visualization. AWS Identity and Access Management gives administrators the ability to define granular and tightly scoped permissions to AWS resources. It is a fundamental principle of information security that any user or service should have the permissions required to perform their function and no more. And while it's tempting to just attach the administrator access policy and move on, spending some time on managing permissions brings huge benefits to your security posture. At its core, IAM consists of 4 key elements: users, groups, roles, and policies. A user is exactly what it sounds like, an individual identity that is usually linked to a real person. Users can be organized into groups like developers, testers, finance, and so on. A role is an identity that can be assumed by a principal, and that principal could be a user, an AWS service, or a compute instance in EC2, Lambda, or one of our container services. And finally, a policy defines a list of permissions and can be attached to a user, group, or role. We recognize that it can be time-consuming to configure least privileged permissions, so we've built a number of tools to make it easier for AWS administrators to create effective and secure policies. These include IAM Access Analyzer, which helps to identify resources which are accessible to entities outside your zone of trust, which is usually an AWS organization, and IAM Policy Simulator, which allows you to test specific actions against a policy to see if the action will be allowed or denied. This can be used as part of an automated testing workflow to ensure that a specific IAM role does or does not give access to certain resources. We also recently released functionality to allow you to quickly and easily generate IAM policies from your CloudTrail logs based on recent activity. Finally, there are some awesome third-party tools which can really help with building best practices IAM policies. One example of this is Cloudsplaining, an open-source tool released by Salesforce which reviews IAM policies in your accounts and provides a prioritized list of recommendations. AWS operate a global infrastructure of 26 geographic regions, with 8 more regions announced, including a second Australian region in Melbourne and our first region in New Zealand. While some customers have fully adopted API-centric serverless services such as AWS API Gateway, AWS Lambda, and Amazon DynamoDB, the vast majority still operate instance-based compute. This could be applications running on Amazon EC2 or in containers on Amazon Elastic Container Service, relational databases using Amazon RDS or Amazon Aurora, data warehouses on Amazon Redshift, or many others. AWS has implemented a secure by default network architecture where only traffic which is explicitly allowed is able to flow. And there are 2 key best practices here. Only allow traffic which is required, and do not attach services directly to the internet unless required. For example, you can place your web or application servers in a private subnet, that is, an area of your network which cannot be reached directly from the internet, and then use application load balancers to route only the required traffic to them. Secondly, there's almost never a need for a database to have direct internet connectivity. If you need to provide access to servers for maintenance, take a look at Amazon System Manager Session Manager, which allows remote access to instances and is managed using standard IAM policies. Now, even with least privilege access in place and a secure network perimeter, unauthorized access is still a risk. An unfortunately common pattern I've seen is the creation of an IAM user for a service, essentially creating an access key and a secret key for that user, and then storing it in a configuration file on a server or within a container. That user might have access to S3 buckets, DynamoDB tables, or other AWS infrastructure. And if those keys are leaked, for example, via a web server misconfiguration or an errant Git commit, those resources are at risk of unauthorized access. Similarly, if human users are using long-lived credentials, that not only makes your joiners, movers, leavers, your JML policy more complex and error-prone, it also opens up the risk of accidental key exposure. While it's possible to somewhat mitigate these risks using IAM conditions, for example limiting access to an S3 bucket to a particular VPC or IP address, it's far better to simply not have those credentials at all. For applications running on AWS Compute, you can use instance roles, which are IAM roles attached to a resource such as an EC2 instance, a Lambda function, or an ECS container, which grant access to AWS resources by means of a short-lived credential generated on demand. This removes the need to store keys in configuration files or code. For human users, you can use AWS Single Sign-On, a free service which provides the users with the ability to generate short-term credentials for use with the AWS console or the command line. If you have secrets you need to protect, such as third-party API keys, database credentials, OAuth tokens, or any other type of secret, these can be stored in AWS Secrets Manager, which provides a secure, auditable store for secrets, as well as automated secret rotation for supported services. I'm going to assume that everyone watching has heard of DevOps, and most of you have probably also heard the term DevSecOps, essentially the process of baking security controls into your CI/CD processes. It's not feasible for everyone in your business to become a security expert, but by building security guardrails for them, you can empower them to innovate and deliver safely. Looking at this very traditional image of the DevOps workflow, one question would be, where does the security go? And the answer is, it goes everywhere. Adding security at every stage can work to shift left security and find vulnerabilities earlier in the dev cycle, and hopefully before they make it to production. Some examples here would include pre-commit hooks to check for AWS access keys in the codebase, using AWS Elastic Container Registry automated scanning to find common vulnerabilities and exposures, or CVEs, using AWS Guard Duty to monitor non-production environments for suspicious activity. I've had a number of conversations where customers or colleagues have told me that data classification is too hard, or something big enterprises do, and I strongly disagree with both of those statements. Knowing what data you have and who has access to it is fundamental to running a successful business. As well as helping your teams make the right decisions when it comes to data, a strong set of data policies are a huge asset when it comes to showing your customers, your partners and investors that you will treat their data with respect. And while you might need a comprehensive classification strategy in the future, it's pretty easy to get started. You have a source code repository with your IP in it. Well, that's internal data, and that shouldn't be shared outside the business. You have some information about your next funding round or your sales pipeline. That's restricted and should be shared only with people with a need to know. What about customer data in a database or an S3 bucket? We'll call that confidential and ensure that you have controls around who has access to it and auditing to ensure that all access is allowed and intended. You could also have a fourth classification of public if you're sharing data widely. Now, this is just the tip of the iceberg, but it's enough to get started. And when asked the question, what's your data classification policy, it's much better to answer, well, we classify data into 4 or 3 or even 1 categories based on these criteria than it is to not have an answer at all. But it doesn't have to be complicated, and it can even be an asset. Imagine a situation where a new team requests access to some historical customer data. Having a data policy gives you a framework to make a quick and correct decision. AWS has a number of tools to help you enforce and audit your data policies. You can use tags on data stores such as S3 buckets to manage access. You can implement row and column level security in your data lake using AWS Lake Formation. And you can search your S3 buckets for personally identifiable information using Amazon Macy. Now, this might seem obvious, but in my experience, this is where most companies struggle when it comes to their security. AWS offers the broadest and deepest set of security features available in any cloud provider today, and our AWS partners continue to bring new innovation in this area. In many ways, it's easier and cheaper to implement great security controls now than it's ever been, but unless the results of those controls are consistently reviewed and acted on, they add limited value. Worse, the fact that the controls exist might lead to overconfidence and a belief that someone somewhere is looking after it. It's vital that your startup works to build the discipline required to triage and fix security issues, and that those fixes target the root cause of the issue rather than just treating the symptoms. There are 3 pieces of advice I would give here. Number 1, look at security automation. In many cases, you can use security events generated by AWS services to drive automated remediation. An example of this would be blocking deployment of a container when it has any high or critical severity CVEs. Another example would be taking a potentially compromised EC2 instance offline and preparing it for forensic analysis. Number 2, Implement some kind of root cause analysis process in your business, even if it's just as simple as a 5 whys meeting once the issue is resolved. And number 3, build security runbooks to ensure that the knowledge of how to resolve issues isn't only in someone's head. Examples here might be revoking AWS access, recovering S3 files from backups in the event of ransomware, or removing unintended public access from an S3 bucket. And yes, I did say there were going to be 10 areas to cover today, but let's add one more, which is incredibly relevant to startups building on AWS. AWS offers over 200 services, and in some cases these services have a significant overlap. If you want to run your application on AWS, you have a choice of a number of compute options. AWS operates a shared responsibility model with our customers. For example, AWS manages the physical security of the data centers in which we host our services, and the customer manages access to their resources. We often refer to this as AWS being responsible for security of the cloud and the customer being responsible for security in the cloud. What I want to point out here is that where the line between AWS and the customer is drawn differs for different services, with AWS taking on more or less operational responsibility. This means that the customer can offload some of the hard work required to secure their environment and focus on building a great product their customers will love. What you can see on this slide is as you move from traditional host-centric compute with EC2 through managed container orchestration with Amazon Elastic Container Service and Container Service for Kubernetes, to serverless containers with AWS Fargate, and finally to serverless functions with AWS Lambda, the amount of management overhead taken on by AWS increases significantly. Managing servers at scale is a hard problem, even for big businesses with a large IT team. With EC2, you get unmatched flexibility, but you're responsible for network security, patching, AMI creation, system hardening, OS optimization, application deployment and orchestration. It's a lot. As you move up the stack, the responsibility for the majority of these tasks moves from the customer to AWS until you arrive at AWS Lambda, where the customer is responsible for managing the application code and not much else. Startups who adopt a serverless-first approach to cloud infrastructure have a significant advantage due to the reduction in operational overhead and the ability to leverage more AWS investment in best practices. I work with a number of fintech startups, and I'm seeing more and more choosing either AWS Lambda or AWS Fargate as their default compute environment because it removes so much of the overhead of building a secure product with undifferentiated heavy lifting such as patching managed by AWS. Of course, the option to move to a less opinionated compute environment is always available, and for workloads requiring GPUs, parallel processing compute clusters, and extremely high-performance instances such as our bare metal EC2 offerings, they'll always be there and improving all the time. So how can you make security your superpower? Many AWS security services can be enabled at the organization level with a couple of clicks. These services will form the foundation of a great security posture. Start looking at how you can find security issues early in your dev cycle with automated security testing. Think about how AWS can help you secure applications and reduce operational overhead and choose the right services for your workload. If you get an alert, fix it, and then make sure you understand why the alert occurred and dig into the root cause. Build a no-blame culture when it comes to security and encourage your teams to escalate early. Now, this is a great question, but what exactly does it mean to be well-architected? Every day, experts at AWS assist customers in architecting systems to take advantage of best practices in the cloud. We work with you on making architectural trade-offs as your designs evolve, and as you deploy these systems into live environments, we learn how well these systems perform and the consequences of those trade-offs. Based on what we've learned, we've created the AWS Well-Architected framework. This provides a consistent set of best practices for customers and partners to evaluate architectures and provides a set of questions you can use to evaluate how well an architecture is aligned to AWS best practices. The AWS Well-Architected framework is based on 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Scan the QR code on your screen now to search Well-Architected framework to find out more. We'd encourage you to get engaged with our training and certification content today. Skill Builder is our online learning content which makes it easier for anyone, from beginners to experienced professionals, to build AWS Cloud skills. We offer over 500 free digital courses that can help you and your team build new cloud skills and learn about the latest services, when and where it's convenient, and in up to 16 languages. As you build your skills, consider preparing for one of our 11 AWS certifications. These industry-recognized certifications span foundational, professional, and specialty levels to validate AWS knowledge and skills, building your credibility and your confidence. A quick reminder to take a look at the new AWS Startup Loft for APJ and get engaged with us today. During this session, you've learned about what we at AWS feel is important to security based on years of experience operating complex systems at a huge scale and working with thousands of customers of all sizes and in all industries. I challenge everyone watching to take some simple steps today. Check your account information is up to date, make sure you're using multi-factor authentication for your root users, and start asking the question, are we well architected? Thank you for joining the session, and please be sure to fill out the session survey. These events are for you, and the feedback helps to make them better and more relevant. Enjoy the rest of the summit, and thank you for watching.